Back on. Let's do another invoice problem, which will be the same one we just did, except the other scenario. Let's say Jolene sells mugs for $5 and t-shirts for $12. And she has total sales of, what was it, 378? She has total sales of 378. Now, last time we said she sold 3 times as many mugs as t-shirts. This time, we're going to tell it to us a different way. They're still going to ask for both these things. One of them is still going to be X, the other one's going to be something else with X in it. But now, they're not going to tell us which one sold more. They're going to say, she sold 56 mugs and t-shirts. They're not going to tell us which one sold more. They're going to tell us how many of them they sold all together. Now, in this situation, where does this 56 go? It actually goes at the bottom of this column, doesn't it? That's the total quantity. In this situation, they don't tell us what was more. They tell us the total quantity. So this is the other way they can tell us the problem. So the invoice problem, they'll either tell us one sold this many times as much as the other, or they'll tell us what the total quantity was. Now, let's pretend we knew one of these. What if we knew that we sold one mug? If we have to sell a total of 56 items, how many t-shirts would we have to sell? 55. That's correct. How did you get that using these two numbers? We subtracted, didn't we? We said 56 minus this thing, right? Total quantity minus this one gives us the other one. What if we sold 4 mugs? How would we find the number of t-shirts? It'd be 56 minus 4, wouldn't it? What if we sold 24 mugs? It'd be 56 minus 24. What if we sold this many mugs, X mugs?
56 minus X.
It'd be 56 minus X. Okay? Whatever we sold of one of them, we subtract that from the total. And that's how we get the other one. Okay? This is a technique that's very helpful. If you're not sure what to do when it's X, just figure out what you would do if you knew what it was. And then do the same thing if it's X. Okay? Now, does it matter which one we let be X and which one we let be 56 minus X? Technically it doesn't, but there's one way we can do it that makes the numbers easier. Notice, if we're going to multiply across here, well, by the way, here's the other trick. We're going to have to put parentheses around this thing, because that's one number. When we multiply by 12, we're going to have to multiply the 12 times the 56, and the 12 times the minus X. Okay. It's called distribution, distributing. When you have something outside parentheses, you've got to multiply both of things inside parentheses. Now, this is the hardest problem in the whole semester. There's only one of them on the test. Actually, there'll be 2 on the test. You'll work one of them and tell me the answers. You'll just set up the other one and show me the equation. Okay. Don't have to solve it. So, don't panic. I've had a number of students that told me, oh my gosh, I was about to drop the class. Because after chapter 5 and 6, I thought, if this is the beginning of the course, what's going to happen at the end of the course? But I want to tell you, this class is the opposite of most classes. It starts in chapter 1, real simple, and gets harder up to chapter 6. But chapters 1 through 4, everybody is supposed to already have had in basic math. And in fact, 5 and 6, we've had some of that in basic math as well. But here's the deal. Chapters 5 and 6 are so important to the rest of the semester that that's why I start with them. If you know 5 and 6, the rest of the semester, all we do is we say, see this new thing? It's just like that thing we did back there in chapter 6, only now we're calling it something different. Instead of calling it a percent increase, we're going to call it a markup on cost. But the math is exactly the same. Instead of calling it a percent increase, we're going to call it a sales tax. That's exactly the same math as a percent increase. Instead of calling it a percent decrease, we're going to call it a trade discount. But the math is exactly the same. So I've had a number of students tell me, boy, once we got past chapter, I thought the first test was the hardest thing in the whole semester. And in some ways, that's true. Because we're learning everything in 5 and 6 that we're going to need to work everything else in the semester. Okay, so I just want to tell you that to encourage you, so you won't get discouraged and think, oh my gosh, if this is the first chapter, what's going to happen later? I don't think it gets any harder. I honestly don't. It's the hardest thing, is the first 2 chapters. Okay, now, let me ask you this. If you had your choice between multiplying 12 times 56 or 5 times 56, wouldn't you rather have a smaller number? Yeah. So, when they tell us the total quantity, we let X be the more expensive item. In the other situation where they told us which one was bigger, we let X be a smaller thing. Here we don't know which one's bigger. So we let X be a more expensive item so that we can let 56 minus X be a less expensive item and it'll keep our numbers small. All right, let's do this and we'll be done with the hardest one. 5 times 56 is 280 maybe? Minus 5 times X is 5X. And 12 times X is 12X. And what do we do with these two numbers? We multiply across, and then we add down, don't we? This is what we spent on mugs, plus what we spent on t-shirts, is what we spent all together. So our equation is this thing plus that thing equals 378. And I'm not going to work that, but if you work out that equation, we'll find out that X equals 14, and 56 minus X equals 42, just like we got before. We get the same answers. It's just a different way of saying it and a different way of setting it up. Okay, let's do something that'll be, after this, chapter 6 is going to seem like a breeze, okay? This is the hardest thing in the whole semester.
Now, break that on down, the 280 minus 580.
You want to see the end of it?
Yeah.
Okay. Twist my arm. 280 minus 5X plus 12X equals 378. And we want to solve for X. Well, can we put these two things together? We got 12 of these guys minus 5 of these guys. So how many of these guys we got? 12 minus 5? 7 of these guys. And these guys happen to be X's. Could have been dogs, they could have been cats, they could have been the number 3. But we got 7 of them. And we still got this 280. Is it a plus 7 or a minus 7? Plus 12 minus 5, that's a plus 7, isn't it? Okay, so we combine those X's. Now we want to get the X term by itself and everything else on the other side. So what are we going to do next? Yeah, we want to get rid of that 280. It's being added to 7X. So let's subtract 280 from both sides. And the 280 becomes 0, and 0 plus 7X is just 7X. So effectively that 280 goes away on the left side, and it gets subtracted from the right side. So we have 7x equals 98. We're almost done. What do we do with that 7? Yeah, divide both sides by 7, because we don't want to know what 7x is, we want to know what 1x is. So x is 14. 14 what? What did we let x equal? It was the more expensive items. It was a t-shirt, wasn't it? And we said, once we know that, we subtract it from the total quantity, 56 minus x. But now that we know that x is 14, we can just subtract it from 56, and we get $42. No, 42. Those aren't dollars. That's quantity. 42 mugs. I was going to say, that's an expensive mug. The mug costs $5, but we sold 42 of them.
The only thing that I'm confused on that is the first step on the, why did you do the 5x plus the 12x? Why not the 280 minus something?
The 280 minus what?
Whatever.
Ah.
I mean, why did you start there?
I could have subtracted 280 from both sides, but eventually I'm going to have to combine those x's. So I just happened to start there. But
So you always combine two x's or two whatever.
two variable terms, that's right.
If it had said minus that, you would have subtracted it.
That's
As
right.
long as there are two x's.
If it had been minus 5x plus 2x, I'm sorry, what do you ask?
If you had a number, say 280 plus 5x minus 2x, it had been reversed. You still are going to solve the 2x problems first, right?
Well, you're going to say, I have
That'd be 3x.
3x, that's right.
And then you did what you need to with the 280.
Right.
Okay.
It's called combining terms that are alike. A term that has a letter in it is called a variable term. A term that doesn't have a letter in it is called a constant term. So we can combine constants and we can combine variables, but we can't combine them with each other because we don't know what the variable is. Does that help?
Yeah.
And then we check it the same way. Okay, let's look at chapter 6 real quickly. This is the first time I've taught this class this way, where we actually had this